So we have next session. If there's a framework which could help you build cloud native control plane without needing to write code, that would be really great, right? So in the upcoming session, Clement will introduce Crossplane, Crossplane, which is a powerful framework. Let's give a warm welcome to Clement.
Thank you. So yeah, hi everybody. So I'm really happy. It's my first time speaking in Taiwan. So yeah, I'm Clement. I'm a platform engineer. I work at Consensus. It's a blockchain company. And as part of platform engineering, I've been using Crossplane for the past 2 years. So I've got a little bit of experience with the project. I'm actually also a contributor on the project. And so yeah, today I wanted to introduce to you guys the project, see how it got started in the first place, a little bit of the evolution, what are the benefits of using Crossplane, and also the control plane approach in general. And then I'm going to show you as well how to get started with Crossplane. All right. So the project itself, Crossplane. So what is it? It's a cloud-native control plane frameworks. So it's a framework in the sense that it reduces the complexity of managing Kubernetes controllers. And Crossplane allows you to manage and provision basically any kind of resources. And then you're able to compose those resources into high-level abstraction. And you do that so that your developer can use those abstraction as a self-service provisioning option. And yeah, Kubernetes is a great control plane for containers. Crossplane teaches it how to manage everything else. So a little bit on how the project got started. So it was created back in 2018. And it was actually founded by the people who worked on the Rook project. So I don't know if you guys are familiar with the Rook project, but basically it was a project that was self-managing distributed storage using Kubernetes. And what it does is orchestrating Ceph using Kubernetes. And so, yeah, that was pretty early on Kubernetes, I think like around 2015. And at the time, CRD weren't really a thing, so they started without CRDs, and then they actually pushed the spec of CRDs, so the whole model of extension within Kubernetes. And so, yeah, working on this project, they recognized the potential of Kubernetes to manage resources beyond the cluster, because, yeah, the self-storage, it was being orchestrated outside the cluster. And so, yeah, so they saw a lot of value in that, and that's why they started Crossplane after this. And the core principle that started Crossplane were separation of concern. So in the sense that developer or workload owners that want to consume resources without knowing the details or they are managed and provisioned. And then on the other side, you have administrator or infrastructure-driven owner that want to tightly control the details of those implementation and define policies on top of those. Another aspect was declarative configuration, in the sense that users specify a desired state rather than the imperative state. And then you have also active reconciliation, so continuously monitoring the actual state against the desired one, and yeah, providing self-healing capabilities. And the last one was dynamic provisioning, so automatically creating, modifying, deleting resources as needed based on what the developer would want to do. So right now, the project actually just proposed CNCF graduation this year. And so they were still in incubating from 2021, and then they were sandboxing in 2020. Today, there are a lot of adapters in production and running Crossplane at scale. you can actually see all of the adopters on the GitHub. So as part of them, you have Nike, Grafana, NASA, SAP, IBM, and many others. It's also great to see that there are many contributors to the project. I think it's one of the top 20 projects within CNCF, and you have about 2,300 people contributing on the project. And yeah, there is a steering committee that has members from Apple, Nokia, and Upbound, which is the company that started initially Crossplane, to lead and steward the project. All right, so now let's talk a little bit about the basic of Crossplane, and let's start with providers. So what is a provider? A provider will both encapsulate a set of what we call managed resources. So those are CRDs, so custom resource definition, to extend what Kubernetes models. And then as part of the provider, you will also have a controller that will watch those managed resources that have been installed, and the controller will be the one responsible to reconcile those resources, and so it will do updates on cloud provider APIs. So let's take an example. For example, one of the providers is AWS S3, and so it will install a bucket managed resource, ACL, versioning, static website configuration. You have many of them. And so if you initiate one of those managed resources, it will then talk to the AWS S3 API to actually manage the lifecycle of those resources. So what does a managed resource look like? So you have one right here. So this is a bucket. So as you can see, the API version, so it's part of the S3 AWS Crossplane API group, and that's a bucket. And so yeah, it's like a Kubernetes resources. You will have a metadata name. Managed resources, they are cluster scopes, so that's why you're never going to see a namespace on those. And so within the spec, what you see is that we have this 4 provider block, and basically this is that's the representation of the external object and the configuration attached to it. And this is a one-to-one mapping of what the AWS API look like, and it's all within Kubernetes. So yeah, and on the right you can see what it looks like when it has been deployed on AWS, and yeah, so there is so as you can see, for example, there was a tag set, and you can see the tags within the interface. Also, what's nice is that it fully uses Kubernetes events. Oh yeah, so first on most of those resources you're gonna have a status, and so the status will enable returning status from the remote API. And so, for example, what can be interesting is the IRN of a resource that maybe you want to reuse somewhere else. And you also have events on those managed resources. And so, yeah, here it was successful, but in case it wasn't, you're going to have the reason on why it wasn't successful using those events. So let's talk a little bit about building provider and the evolution. So in theory, it's possible to use any language to build those providers as long as you have a Kubernetes client. But there is a golden path, which is using Go, as most of the Kubernetes environment is using it. It enables having a shared language. Another package that you use for a provider is the Crossplane runtime, and that's going to be a set of library to interact with Crossplane. So it's going to make it very, very easy to interact with composition, manage resources using that package. And then one that you might be familiar with is KubeBuilder. KubeBuilder is a framework for building operators and also a custom resource definition. So by defining a ghost struct, it's going to build automatically the CRD based on that. And another aspect around provider is code generation. So one of the challenge with Crossplane was getting a good coverage of the main cloud provider. But this was a bit challenging because like on AWS you have about 900 resources. And so if you want to implement that all manually, it's a lot of work. So that's how it got started first, kind of as a proof that it could be done. But then you had other operators that were code-generated. At first from cloud provider operators, so you may be familiar with AWS Cloud Controller Kubernetes, and ASO is the Azure Service Operator. So basically, they were doing something pretty similar to Crossplane, but it's just, it was for their specific cloud. Crossplane allow you to manage have multiple implementation within the same cluster. And so that was the first version, and then they started co-generating from Terraform, so we had the first version of TerraJet, and then currently there is a new one, which is Object, which is their second generation, and it has much more customization points. It also generates documentation for the resources automatically, and infer reference, because in Crossplane you're able to reference managed resources from a managed resources, and it's also much more stable. Some of the recent development includes supporting multi-version APIs, so that's quite nice. When there is a breaking change on an API, you're going to be able to version those CRD, and it's also going to generate automatically a conversion webhook. So there is really no work to do on your end, except migrating the API version. Recent addition as well is manage resource metrics. So all the provider gets metrics about the status, is it ready and synced. You also have TTR, so time to reconcile and time to readiness, to know how much time it took for your resources to get healthy. And then you also have a drift metric. One of the big change in Object was the support for Terraform plugin framework. Before that, Crossplane was using Terraform CLI. So it was forking the Terraform CLI, which was a bit inefficient. And so, using the Terraform plugin is much more stable and enable managing many more resources with less memory and CPU footprint. All right, so let's talk about how to build your control plane, and in particular, composition and function. So one of the goals of building a platform is to assemble those granular resources that we saw, the managed resources, into a high-level abstraction so that developer can self-service those custom API. And so we talk about composition, so you will compose those resources such as an EKS cluster, a VPC, subnet, NAT gateway, EIPs, and package them as a single API, an abstraction. So for example, a cluster. And developer will have a limited view on the configuration, and you will have guardrails, and it will hide the complexity of the implementation. You're just exposing the parameters that are useful to them. So and it's all done within Kubernetes, and so you can it's still compatible with kubectl and GitOps tooling, and no code is required to build those composition. So let's look a little bit of what it looks like. So on the left, you have a developer. So a developer will consume the claim. So you are claiming infrastructure. The composite resource definition, think of it as basically declaring the schema of your API. And then the composition is going to be an implementation for that schema. And that's where you will find the different managed resources. If we take an example, the claim could be a Postgre SQL database. And so you will have an XRD for that, and AWS composition, and the AWS composition will have an RDS instance, a DB parameter group, and security group, so that everything is configured and ready to use for the developer. Let's look a little bit how it looks like to configure those composite resource definition. So you see that as part of the spec, you're defining the group of the API and also the kind. So we are creating a new CRD within Kubernetes when we are applying this manifest. And then at the bottom, you have an open API schema field, and this is what will allow you to define your schema, the schema of the CRD that is generated. And now the composition. So as you can see, as part of the spec, this composition will reference the composite resource. So you have a composite resource type ref, and we are referencing the type that we just declared. And as part of the spec, you also have pipeline. So that's kind of a new addition within Crossplane, which are function. And so within that function, that's where you're going to be generating the resources. What can function do? So you can run a pipeline of function to compose the resources, I was saying. They can be written in the language of your choice so that you implement your unique logic. And they're kind of the sweet spot between a no-code experience and building an entire controller on your own. Because it will allow you to mostly focus on your unique needs, and Crossplane do the heavy lifting of creating the resources, reconciling, and yeah. Writing code is actually optional. So some of those functions, they can be Go template, QScript, KCL. And yeah, it was thought out as something that will enable having reusable action. So the goal is not to generate a function for every specific need that you have, but instead build something that is composable and reusable. But if you do want to write functions, that's what it will look like. So what you have to do is define that run function, and that's where you will define what gets generated. So you have access to a context, and basically that's where you will get the data about the claim that was called. And within the run function, that's where you're going to be generating resources. And so, as you can see, we are defining a bucket in the US East 2 region, and then just returning that. Another example is using those generic functions, and so that's the Go template function. And so yeah, it looks pretty similar to Helm or yeah, Go template. And for example, one thing that was hard to do before is using for loop. And so yeah, using Go templates, it's not very easy. So you get so for example, we are looking at in the composite resource how many resources were defined as part of the spec, and then we're iterating over it, and then creating instance for each of those instances. Actually, before having function, there was a native API that was called patch and transform, and so it's still fully compatible with patch and transform. Now it's just implemented as a function. It's actually very easy to migrate from patch and from transform to function. And so, yeah, patch and transform is the no-code approach. So you're basically defining resources and patches on top of those resources. So now let's talk about what's the benefit of the Kubernetes controller paradigm, and why it's interesting for control planes. So the control plane approach with Crossplane enables you having a unified resource management experience. You have a single API to manage infrastructure and application, and that allows you to have a consistent interface for various services. Yeah, as we said earlier, it allows having declarative configuration. One big aspect of Crossplane is bringing multi-cloud compatibility. Because you can abstract away provider-specific detail and have multiple implementation for the same service. Like, let's say you have a database, you could offer it on AWS and Azure as two different implementation of the same API. And so yeah, it enables you to promote cloud-agnostic design and reduce vendor locked-in. And yeah, the whole concept about extensibility, you're able to define a new set of APIs. So, and what are the advantages of the control plane approach? it simplifies operation because you have a centralized management. It reduces complexity and operational overhead. It increases also consistency across environment and project. That was something something pretty challenging, at least in my company, and having Crossplane really make it easier to have kind of the same configuration across our different environment and projects. Also, the advantage is having better developer experience. You're providing a self-service capability. It really reduced the onboarding time. And what's nice is that you're also reducing context switching, because instead of having to go to multiple cloud console or multiple tools, you now have this single API that you can offer to your developer. And also one benefit is the consistent governance. So you can enforce policy in one place. And also easier auditing. Actually, it's something that is going to be, that's the main topic for the next release of Crossplane. They are implementing a cloud log. And yeah, because now you have to go through events and log at the provider side. And tomorrow you're going to have a unified log of all the actions. So it's going to be really easy to audit every action in Crossplane. About the so let's talk about the controller, the Kubernetes controller characteristic. So they are resilient and self-healing because you have this continuous reconciliation loop. So they use what we call level triggered instead of edge trigger because they respond to current event, to current state rather than looking at event change. So a controller can stop and restart, and if he misses an event, he's just gonna look at the state that was defined within the CRD. It simplifies state management because it's instead of describing transition logic, you're just describing the end state. And yeah, natively Kubernetes controller are quite efficient because it has deduplication of item in the work queue. So that means if you're creating your resources and then updating it another time, in the end in the work queue we'll have only one resources, and so it's just one action for the controller. They were all compressed down to one representation. You also have no concurrent reconciliation, so that means you are avoiding having race condition and conflict that could happen. And yeah, nice capability also is rate limited retries with exponential backoff. So that means if there is an error while processing an item, it's going to add time every time it's going to retry to do this action. Let's say 1 minute, 2 minutes, 5 minutes, 30 minutes. And so that avoid overloading external system. And it's also the reliability. So if if a Kubernetes controller crash, it always reprocesses all of the item on startup. And what's nice is that you also Kubernetes resources are read from an in-memory cache, and so that avoids that reduces API server communication. All right, so if you want to start implementing Crossplane, what will be the step-by-step approach? I think the easiest option is address your immediate needs. For example, myself, I've started with a simple task, managing database permission. And so creating user, granting permission to user on the database, and then automatically creating secrets for developer access. That was something a bit tricky to do with Terraform, and Crossplane made it really easy to do. And then once you're comfortable with Crossplane, then you can go to provisioning full cluster. And then once you have automated cluster creation, you can focus on cluster consume services. So that could be database, cache, container, registry, storage solution. And so yeah, I think one of the key principles for adoption are implementing gradually, starting where other tools have gaps. And yeah, it's really important to build on complexity as the team familiarity grows with the tool. And that's something also, the API that you offer, they can be continuously improved and expanded. Finally, let's see how we can integrate those custom API that we create with Crossplane. So one of the easiest solutions will be using GitOps. So you will commit those claims to GitHub, and then use Argo CD. Argo CD will pull the changes from GitHub and sync with Kubernetes, and that's how you will deploy your resources. So usually developers use already that for workload, so now they can manage both their workload and their infrastructure in the same place. And so, yeah, actually that's one of the examples that we are running. So at my company, we are running an observability platform using only Crossplane resources. So we have Loki, Mimir, and Tempo, and we have a Kubernetes cluster. At the top, we have SQL instance, and so it's all provisioned using Crossplane. What's nice is that you have also other tools within the CNCF ecosystem. So, for example, Backstage is one of them. So it's developer portal framework, and so you could expose the configuration of your API through a template, and so developer will fill a form that looks like this, and it will generate the resources for this API, and it can automatically open a PR on a repo. So yeah, developers don't have to read a documentation and write YAML. They can only have a form to create new resources. And lastly, you can also have completely custom integration. At the end of the day, Kubernetes is just a REST API where any CRD is addressable. And so you can imagine having an API in front of your Kubernetes cluster. I know Elastic, that's what they do. You can also have a CLI that interact with Kubernetes, so that your developer could manage infrastructure using a CLI, or developing a whole UI on your own as well. If you want to get involved with the Crossplane project, so I put some of the link. I think the nicest place to be around is the Slack. There are a lot of discussion happening over there. Yeah, and on YouTube you can find the community meeting that are happening every month. So yeah, that's about it for me. Thank you, everybody.
So anyone have any questions? Okay, go ahead.
Sorry, I'm Sherry, and I want to ask that what kind of motivation that we can introduce this project, because I think that introduce this project need to some effort, and so what kind of challenges for us that we can decide to switch or move to using this project? Thank you.
Yeah, that's an interesting question. Because you have already a lot of tools in the ecosystem that do things pretty similar, but I guess one of the most important selling points is having defining APIs within Kubernetes, and so that make them pretty accessible, and it's more customizable. Then apart from like POCing and showing the value of the tool, I think that's how I did it. Like, we had an internal hackathon in my company, and I showed what could be done with it, and people directly saw the value of what the tool brought. As I was explaining, I guess start small. You don't have to build like full cluster automation. You can start very small to show the value of the tool.
Okay, thank you. Okay.
Hi, Kerman. Let's talk. I have a project because I am first time heard this project, and I am curious. How about on-premise Kubernetes? You can use a Crossplane or not? Because you talk sharing about cloud private, right? Cloud private. But I am working on the on-premise Kubernetes, so I am curious. The Crossplane can use it at on-premise Kubernetes. Thank you.
So yeah, you can install Crossplane anywhere. So it's just a set of deployment and CRD that you install on your cluster. Maybe your question is around like, can you do to manage on-premise API. So I guess it's going to depend on what is used. I know there is pretty good coverage for an OpenStack provider. I used to work on premise. Now I'm all in the cloud, and I think it's most of there is really good support for the cloud, and I think it's getting there for the on-premise. So I know it's good for OpenStack. It's going to depend which one you use.
Okay, thank you for your sharing. Because I was do a lot engineering in Terraform. So your speech is very inspired me to do this thing on the Crossplane. And my question is about the secret of your IAC platform. Because if you want to use your Crossplane to manage a really large scale cloud service, you must have a privilege to change the cloud resource. So how do you manage this credential in your structure?
Yeah, that's a really good question. So yeah, it's possible to use access key, but that's definitely not how I did it. No, it's fully compatible with IRSA, so you can use service account to authenticate, for example, on AWS. I know it's also supported on, so I did it on AWS, but it's also possible to do it on Azure. I'm pretty sure it's also possible to do it on GCP. So yeah, you can make advantage of it's IRSA, it's service, IAM for Kubernetes service account.
So you use service account to manage the privilege?
Yeah, because basically IRSA, so service account, you're going to attach an annotation to your service account, and it's going to be linked to a role. And then on the role, that's where you're putting the policy on what permission.
The second question is, how do you manage the service account? Because the service account is also provided resource too.
Is a provider resource?
Yeah, it's a cloud resource service account.
No, I mean the service account.
Service account mapping to a cloud service account, but you still have to manage a cloud service account. For example, at AWS, you have to manage the role, and how do you manage that?
So I show the S3 resources, but you have the same for IAM API. So you're able to create role, create policy. You have role policy attachment to mount those permissions. You can also there is 100% coverage on AWS, so you can really manage the whole lifecycle, even permission. That makes sense?
I mean, a little like a self-reference problem, because you must have a egg, then you have a chicken. So if you use the Crossplane to manage your AWS service account, then how do you manage the super privilege service account for that?
Yeah, right. The control plane one, the first one, you're going to do things a bit manually, but you can imagine having the whole process automated for manage environment. Like if you can use Identity Center to create new account and then the permission associated with them. So yeah, there are ways to do it, but yeah, I guess the first one, you have a chicken egg problem. Yeah.
Sounds like a boot service account.
Yep.
Okay, so we are going to run out of time. So if you have any further questions, feel free to come here and discuss with Clement. And let's give a big thanks to Clement. Yeah, thank you for your awesome service.